In this video, I'm working out the practice exercises at the end of the probability chapter. Let's begin with number 1. What's the probability of throwing one die and getting the number greater than 5? Well, a die has 6 faces, and 1, 2, 3, 4, 5, 6, and greater than 4 we only have 5 and 6, so 2 out of 6. So your answer should be 2 over 6, and if you want to reduce it, it's 1 over 3. Number 2, what's the probability of throwing 2 dice and getting the sum of the following numbers greater than 3? All right, if you throw 2 dice, how many outcomes are there? Well, if the first die has 6 outcomes and the second one has 6 outcomes, together it will be 6 times 6, 36 outcomes. Let me give you some more details on this question. What are the outcomes? When you throw 2 dice together, you could get 1, 1, 1, 2, 1, 3, etc., 1, 6. Or you could get 2, 1, 2, 2, 2, 3, all the way to 2, 6. And then you could get 3, 1, all the way to 3, 6. Or you could get 4 with 1, 4 with 2, 4 with 3, 4 with 5, 4 with 4, 4 with 6. And then 5, 1, etc., 5, 6. And then finally 6, 1, all the way to 6, 6. These are, if you count them, guys, you're going to get 36. 6 plus 6 plus 6 plus 6 plus 6 plus 6 will be 36. He said, what's the probability of throwing 2 dice and getting the sum of the following numbers to be greater than 3? Well, the chance is very good, because the only outcome that doesn't give you a sum, so greater than 3 means 4 and up. Look, if you look at 1, 1, 1 plus 1 is going to give me a 2. We don't want that. If you look at 1 plus 2, that's going to give me a 3. That's not bigger than 4. That's not going to work. 1, 3, that is 4. It's not bigger than 4, so that's not going to work. 2, 1, that's a 3, not bigger than 4. That's not going to work. 2, 2 is not going to work. 2, 3 works, because 2 plus 3 is 5, bigger than 4. What about 3, 1? 3, 1 is 4. That's not going to work. So these, the only 1, 2, 3, 4, 5, 6, the only 6 that don't work. So how many of them would be in our favor? Will be 30. Will be 30, because we have 36 outcomes. So your answer should be 30 divided by 36. So rather than counting the ordered pairs that will give me 5, a sum of 5 and up, I just counted the ones that give me 4 and below, because they're shorter. There are not too many of those, and subtracted them from 36. So 30 over 36, that would be the answer to number 2. Number 3. What's the probability of flipping a coin and getting a head falling 5 times in a row? Okay. Think about it as tossing 5 coins. What would be the probability of getting 5 heads? Well, on the first one, the probability is only 1/2, because there's head and tail. In the second one, it's 1/2. On the third one is 1/2. In the fourth one, it's 1/2. And in the fifth one, 1/2. Since those 5 events are happening together, and you want to find the probability of the 5 events happening together, you multiply probabilities. So your answer should be 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2 times 1 over 2, which is 1 over 32. If this question was flipping 2 coins and getting 2 heads, it will be 1 over 2 times 1 over 2, which is 1 over 4. And like talking, just about 2 coins, let me show you all the outcomes, when you do 2 coins. You could either get head, tail, tail, head, tail, tail, head, head. These are the only 4 outcomes if you flip 2 coins. Okay. There's only 1 outcomes that will give you 2 heads. So the answer will be 1 out of 4. How did we figure out the 1 over 4? You could have done the first one is 1 over 2. The second coin is 1 over 2. And you multiply them together, you get 1 over 4. Okay. Number 4. The customer wants to buy a bread in a can. There are 30 pieces of bread in the shop, including 5 from the previous day, and 20 cans with unreadable expiration dates, of which one has expired. So we have 5 bread from the previous day out of 30, and 20 cans with no unreadable expiration date, for which one has expired. What's the probability that the customer will buy a fresh bread and a tin still under warranty? Okay, so 4. We need fresh bread and tin under warranty. And once I say and, this is a multiplication problem. You're multiplying the probabilities because the events are independent. The bread has nothing to do with the cans. You're going to pick from the bread and then you're going to pick from the cans. Okay, since there are 30 pieces of bread and 5 of them are not fresh, so there are 25 fresh. So the probability of selecting a fresh bread will be 25 out of 30 times. Since we have 20 cans and one of them has expired, what's the probability of selecting one that did not expire? We'll still have 19, so it's 19 out of what? 20. And your answer will be 25 over 30 times 19 over 20. You can multiply them if you want. We can reduce them a little bit. I can reduce by 5 and by 5, so that would be 5 over 6 times 19 over 20. And 5 over times 19 is 95 over 120. And if you want to change this to a decimal, 95 divided by 120, that will give me 0. Let's say he wants the answer to 3 decimal places, so it will be 0.792. Number 5. What's the probability of throwing one dice 7 times in a row and getting the number 6 falling exactly? Okay. I want to change this one. What's the probability of throwing a dice 3 times? I meant to change it before, but I forgot. 3 times in a row and getting the number 6 falling exactly 3 times. Well, the probability of getting 6 is 1 out of 6 because there are 6 faces. 1 over 1, 2, 3, 4, 5, 6. This is on the first die. On the second die is going to be 1 over 6, and on the third one is going to be 1 over 6, and you multiply the 3. So it will be 1 over 216. 6. We have 100 tickets in the hat, numbered from 1 to 100. What's the probability that you'll pull out a number that's divisible by 5? Well, what are the numbers that are divisible by 5? So we have 5, 10, 15, 20, 25, 30. You count them, guys. 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85, 90, 95, and then 100. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I mean, you could tell it's 20 because 5, 10, then 15, 20. So it's 2 in each set of 10. So there will be 20. So your answer should be 20 over 100 or 1 over 5 or 0.2. 7. Johnny wrote a random natural number from 1 to 20. Determine the probability that he wrote a prime number. Okay, the possible outcomes is 20. We have a total of 20 numbers, so that's the denominator. Denominator is everything, all the outcomes. Now, the numerator, we want the one that would work in our favor, which are the prime numbers. So what are the prime numbers between 1 and 20? Remember, 1 is not a prime number. So we have 2, 3 is prime, 5 is prime, 7 is prime, 8, 9, they're not prime number, 11 is, 12 is not, 13 is, 14, 15 are not, 16 not, 17 yes, 18 is not a prime number and 19 is a prime number. How many? I don't care what the values are, guys. All we care about how many. Count them. 1, 2, 3, 4, 5, 6, 7, 8. So 8 over 20 can reduce by 4. You get 2 over 5. And if you want to change it to a decimal, it would be 0.40. Okay, 8. Let's see what 8 is. 3 shooters shoot at the same target. Each of them shoot just once. The first one hits the target with a probability of 70%. The second one hits the target with a chance of 80%. And the third one with a probability of 90%. What's the probability that none of the shooters will hit the target? Okay. Number 8. Probability of none of them will hit the target means probability of first one doesn't hit, second one doesn't hit, and third shooter doesn't hit, equals the probability that the first one doesn't hit, the second one doesn't hit, the third one doesn't hit is the probability of the first one doesn't hit times the probability of the second one doesn't hit times the probability of the third one doesn't hit. We know the first one hits the target with a chance of 70%. What's the chance that he doesn't hit? Well, if it is a 70% of success, what's the chance of failure? It's 30%. If you ask me how do I figure this out, the probability of hit plus probability doesn't hit should always equal to 1. For example, guys, if the probability that it will snow today is 70%, that means the probability that it doesn't snow is 30%, and it's the same thing here. So that will be a 30%, which is 0.3 times. The second shooter hits with a probability of 80%. What's the probability that he doesn't hit? 0.20. The third shooter hits with a probability of 90%. What's the probability that he doesn't hit? It's 0.10, and you just multiply those three numbers. So 0.3 times 0.2 times 0.1, and I get 0.00. So there is a very small chance that the three of them will shoot at the target and doesn't hit. It's a very low probability. If you want to change this one to a percent, guys, how do you change the answer to a percent? You just move the decimal place 2 digits to the right, so it will be 0.6%. You see, it's even less than 1% chance. What about if I give you this question and ask you what's the probability that the three of them will hit the target? So instead of putting 0.3 times 0.2 times 0.1, you will put 0.7 times 0.8 times 0.9. Okay, so that's number 8. Now number 9. That's the last one. Use a contingency table to answer the following questions. What is the probability of a passenger on the Titanic surviving given that he or she was in first class? So we need a probability of surviving given first class. All right. Here's how you do that. So we want the probability to pick a passenger on the Titanic given that a surviving passenger on the given that the person was a first class. Once he put the given condition on us, we are required only to pick from the pool, just of this set right here, because he says given of first class. So we're not gonna pick from take everybody or take all the possible outcomes. So my possible outcomes will be the passengers in the first class. So if you are asked a given conditional probability, and he says given that he or she was in first class, your first thing is to figure out what's the total of the first class. the total of the first class is 325. That should go to the denominator. So this one always go to the denominator. Now what goes in the numerator? In the numerator, find out how many survived and were first class. So this is survived right here, and first class, where the 2 meet is right here. So that will be 203 divided by 325. B, what's the probability of a passenger being in first class given that the passenger survived? So probability of first class given survived. Just like what I said in the previous question. Okay, what comes after giving goes into the denominator. So figure out the total of passengers who survived. What is the total of passengers who survived? It's 711. So just put 711. In your numerator, you want to find the intersection between the first class and survived, which we did it already. It's 203. So just put the 203 here. C, what's the probability of passenger being a crew given that he or she survived? Crew given survived. Okay. Equals. Again, this is going to go to the denominator, total of survivors. Not the crew survivor, all survivors. We have 711. Now we want a crew who survived. Okay, this is a crew right here, and who survived. So you just do a horizontal line, a crew will be 212. D, what's the probability of selecting a passenger who was in the first class or survived? First class or survived. Okay, this is addition rule. When he gives you two events and there is an or in between, you do the probability of the first event. So what's the probability of the first class? We don't have conditional probability anymore. Probability of first class, what's the probability of selecting a person who happened to be a first class? Total of first class is 325 divided by 2,201. That's the grand total. Plus probability of survived. What's the probability of selecting a passenger who survived? I have 711 divided by 2,201 minus, this is the addition rule. The addition rule says the probability of A or B, I'll write it down here, equals probability of A plus probability of B minus probability of A and B. So we got the probability of first class plus probability of survived now minus probability of first class and survived. The denominator doesn't change. Okay, first class and survived is 203. And you just do the math here. So that will be 325. Let me just do that. Plus 711 minus 203. 833 divided by 2,201. Last question. What is the probability of selecting a passenger who died and was a crew? So probability died and crew. And is intersection, guys. So you have to look at the intersection. We're selecting from all passengers, no conditional probability here. So it's 2,201. And we need now how many died and were crew. These are a crew, and the died right here. Watch, guys. And where do they meet? 673. And if you divide 673 by 2,201, you will get round to 3 or 4 decimal places. It will be 306.